Okay, example 2 of curve straightening. So we have some data that is relating potential energy on the y-axis and height on the x-axis, and we're being asked to find the mass of the object. So remember, the first step is to try to find a physics equation, and the physics equation has to have these three things in it. So the quantity on the y-axis, which here is potential energy, the quantity on the x-axis, which is height, and here we're being asked to find mass. If you remember back to physics 20, the formula that has these three things in it is that one there, EP equals mgh. And the formula is allowed to have more than these three variables, but it has to have at least those three, which it does. Now, step 2 is to modify the data to get a linear graph, but as we can see, our graph is already a straight line, so we're going to skip step 2. Now, for step 3, we're going to find the numerical slope of the graph. So we're going to calculate the slope by choosing 2 points that are not data points. Here I'm going to use 0, 0, because that's not a data point, and I think I'm going to use this one here. I am looking for places where I don't have to estimate. So those 2 points that I picked in red, they cross the grid lines in a nice spot. So I'm just going to draw some dotted lines to help me read what the values of those points are. And now I'm going to go ahead and do my slope calculation. So for slope, I've got 0.75 kilojoules minus 0 over 29 meters minus 0. And when I go ahead and do that, I find 0.0258 kilojoules over meters is my slope. Now, I don't really want to work in kilojoules because the standard unit would be the joule, not the kilojoule. So I'm going to go ahead and multiply my answer by 1,000 just to put it into joules instead. So when I multiply by 1,000, I get 25.8 joules per meter. And the other thing I'm going to do here before I keep going is I'm going to do the units and just try to simplify them as much as I can. So remember that a joule is a kilogram meter squared per second squared. So here I have a joule over a meter. So that's a kilogram meter squared per second squared all over a meter. Now that meter on the bottom, I think I'll write that as meters over 1. And now I'm going to do the kiss and flip thing so that I can simplify my units properly. So I keep the top of the fraction, so this part that I'm circling, I keep that the same. And then the bottom part that I'm putting a star beside, that flips. Okay, and then now I'm going to go ahead and I'm going to cancel one of the meters up top with the meter on the bottom, leaving me with kilogram meter per second squared. So for my slope, I'm going to write this as 25.8 kilogram meter per second squared. Okay, now that's my numerical slope. It's not my answer to the question yet. Now we're going to try to fill in this chart. And so first thing I'm going to fill in is y and x. Remember, y is just whatever's on the y-axis of the graph. So that's EP. X is whatever's on the x-axis, which is h. And so x and y, that's done. Now I'm going to figure out s and b. Let's start with s. So to figure out s, we're going to write down the physics equation that we had found back in step 1, and it was EP equals mgh. And remember that we're going to cover up whatever the x variable is. So pretend here's me covering up h because h is our x variable. Whatever is left, so this part that I'm circling, that is what s is. So I'm going to go up here and write down s. So s is mg. Remember that that's going to be the algebraic slope because it's not numbers, it's a collection of letters. And remember for b, if the formula has no plus or minus sign in it, then b is going to be 0. And the formula, I'll just write it down again, it's just EP equals mgh. There's no plus or minus in there, so that's just going to be 0. Okay, and then this is the last step. So now I have to make my numerical slope equal to my algebraic slope. So my numerical slope was 25.8 kilogram meters per second squared. And my algebraic slope was mg. And I'll just make a note over here. If you remember from physics 20, g is 9.81 meters per second squared. So what I'm gonna do is I'm gonna take this equation that I'm circling and I'm going to solve for m because that's what the question was asking. So I'm gonna divide on both sides by g so that I get m by itself. And now I'm gonna plug in a value for g. So g is 9.81 meters per second squared. And if you go ahead and you put that in your calculator, you're gonna get approximately 2.63. And let's just have a look at the units. So I'm gonna take these units here and I'm gonna do kiss and flip. So I'm gonna leave the units on top the same, so the kilogram meters per second squared remains the same. And then I'm gonna flip the units on the bottom like that. And then now I can see how it's gonna cancel. So second squared cancels second squared, meters cancels meters, and we can see there we're just left with kilograms, which is good because masses have units of kilograms. If I didn't get kilograms in the end, that would probably mean that I did something wrong along the way, and it would be a hint to go double check my work. But there's our final answer, 2.63 kilograms.